Today we'll be looking at how to write your custom functions or how to call your custom C functions from assembly. So in the last video we saw how to call the standard output function, which is printf, but today I'll be showing you how to call your own function, your own C functions inside assembly. So let us start by creating maybe a C file. So maybe I'll name it main.c. You can name it whatever you want. Then we want maybe a function that takes a name as an input or as an argument, then prints the name alongside the greeting. So that's easy in C. So what we have to do, let us include the standard input and output stdio.h. .h. Then here we will define our function, which will be return a void, meaning that it won't return any value. I'll name it greet, then followed by a set of parentheses. So our argument will be a string, meaning it is a pointer to a character, so we'll name it name. So this is how we represent a string in C, so a pointer to a character. Then we'll go ahead and maybe print, we use the printf, so printf, then we just type hello followed by a formatted string, meaning that we want to put a string in place here, followed by the name of the argument, then we finish with a semicolon. So after defining our function, we have to export it so that it can be available to the outside environment, like in our case inside assembly. So we use again the extern keyword followed by the return type of the function followed by the name of the function, then you define what arguments that you expect. So it's a character input or a string, so and it has this. So here we defined our function here, then here we exporting our C function so that it can be available in our assembly code. So with that, we have our C file ready, or it's ready. So we'll go ahead and write our assembly. So I'll name it maybe custom.s. Then we'll go ahead, because we are passing some string, we'll define or we'll hard code our name string inside the data section. So data followed by, maybe I will name it name, then db, because we want 1 byte, maybe let's say James, or you can put your name, or Edward, let us put that, then followed by a 10, meaning this, it should print on a new line, again a 0, meaning that it is a null terminated string. So after doing that, we'll go ahead straight into our text section where we'll be writing our source code. So as you can remember in the previous video, we said that if you're interfacing with C, you have to use the start main label instead of the traditional start _ start that we defined, which is inbuilt inside assembly. So we'll use global main because we're interfacing with C. Then we use our label just like that. So as you can remember, we will first push our argument or our argument or our name inside the stack, call the function, then which will go to the stack, look at the top value, it will take the value, then it will print it, then we exit our program. So before doing that, we have to use now a function which we use extern greet. This is a custom function. Then we have now use the exit to exit our program. Now, so we'll go ahead and push the name first. So as you can remember, the stack is a LIFO, so last in first out. So the last element to be pushed to the stack will be the first to get out of the stack. And functions works like if you call the function, it will go to the stack and take the top value and print it. So we'll first push the value that we want the function to find, so which is the name, or the variable, the name, which is this. Then we'll go ahead and call, what are we calling? Our greet function. So this, when it reaches here, it will go to the stack and look for that name or the value that will be at the top. It will take it, then print it, then pops out that variable. So after doing that, we have now to push again a 0 at the top, then exit, which will take now that 0 and give it a status code of 0. So here it will look like this. So in our traditional C function, it will look like that. Now after doing that, we have completed our assembly file. So as you can see, when interfacing with an external language like C, our assembly code size reduces drastically, because doing this in maybe pure assembly, it may be some few lines of code or some few million lines of code, but with C you can see that it's simple. Now after doing that, let us compile it. So we'll compile it as usual using NASM, so which will be ELF32, followed by our assembly file. Then we generate our object file, we'll call it custom.o. So we have an issue. So what have we not done? So I forgot to call the exit here. So remember, we use call to call a specific function. So and exit is a function. So don't forget to put the call. So after doing that, let us recompile it again. So we have no problem after assembling it. Now let us link it using GCC. So GCC, we use the no-pi flag, meaning that we want this program, when it runs, it will run in the same memory location. So we don't want the program to run in different locations. Then we define our architecture, which is an M32. So use the -M32 flag. Now followed now by the name of the C file. So it was main.c, followed by the object file that we have assembled. So custom.o. So custom.o. Then /o, now our binary, which we'll call again, let us call it custom again. So with that, you can see it has compiled, but as you can remember, we got this warning over here. It's a warning, but the program will run regardless, because if we run, so as you can see, it has produced a binary here. So if I run it like that, you can see now the name is being printed over here. But if you want to suppress the warning, you take this here, copy it. After copying it, let's go back to our assembly, and at the bottom or wherever we have to paste it. Then don't forget, because it is a separate section. So this means that or tells the assembly or the assembler this is an executable stack, so it will be executed by a program when it runs. So when I try to recompile it, you'll see now the error will have gone. Then let me link it. Now if I run it like that, you can see now my name or the function that we created in the C programming language is being printed. So just an overview. So we have defined our string data here, which will pass as an argument to the function that we defined in the C file. So this is the C file. So this one over here. So this name will be passed, the name which is in the data section will be passed here. So this is the argument that we want. Then Here we define our usual text where our source code begins. Then we make sure we have we tell the assembly that we want to use to get this greet and exit function, which will be looked upon when we link our file. So it will go ahead and look for this greet, which we have provided main.c inside the linking part using GCC. Then the exit is the inbuilt function in the standard library. Then this is our global starting point, so which is main. Now we push the name that we defined here. Then we call greet. Greet will go on the top of the stack, take the name and pass it as an argument. Then we push again 0 at the top of the stack. Then we call exit to tell it to take the 0, meaning that we want our return status will be 0. So that's simply it. There is no big deal about it. So if you have any question, you can ask. I'll be happy to reply to you. And if this video has been helpful to you, just like, subscribe, and show some love. So that's all for today's video, and see you on the next one.